Okay, so take that, 0 to 3.6, negative x squared plus 10x minus 23, and I get that. Because 0 takes out everything. Because of the 23x. It takes that out, takes that out, takes that out. So 3.6, see what you get there. Now I'm not doing any of the regions under and above. I'm not doing that yet. I'm just getting an area. Okay? Basically this tells us that, okay, this tells us that it's below the, and that's probably where we were wrong there. This negative tells us that it's below the x-axis. So leave that negative there. And here I did 3.6 to 6.4, and here is 6.4, and then I just minused this right here, which is 3.6, and I got 3.77. Yep, it's positive. So the area, oops, sorry. See the area up here, if you graph it, you probably see that the area up here is a little bit smaller than these two areas. So I got 3.77. And then the next picture, let me get there. I don't know why it's blurred. I don't know, it must be something wrong with my camera. Anyway, at 8 and 6.4, plug in 8, and I got negative 4.89, which again tells us that it is below, so we don't need to just forget this because I didn't do the math right because I put negative. So that would be negative 3.55 plus 3.77 minus 4.89. So take your handy dandy calculator. Negative 33.55 plus 3.77 plus or minus 4.89. A negative 34 point, didn't y'all get negative 33 something yesterday? Or something like that. Negative 34.67. I'll try to keep them above the dadgum x-axis. How about that? It'd be a whole lot easier. But you'll see the difference of two curves. You'll see that here today when we get finished today. Okay? How did I get rid of this? Let's see. Oh, me oh my. Oh, I need to pull up the whiteboard. There we go. All right, now I got a bunch of things to import today, so I'm going to we'll go ahead and import them so y'all can actually write them down. You do have them in your book. I don't think it's going to pull up like I want it to. It's kind of blurry. Nope. So just forget that. I pulled in some extras, so just hold on. Delete. Bring in individuals. Okay, that's the derivative of 1 over x, or x to the negative 1. That's the exponential rule and e to the x. This is an example right here of this. So you got three rules: 1 over x, or x to the negative 1, e to the x, and exponential rule, b to the x. That could be any number like 5 to the x or 4 to the x or this is your basic power rule that we've already discussed. That says, I'll pull it up in a minute. Let me make these a little bit smaller now that you've This is what we learned yesterday. A couple of examples. So right now you're responsible for this guy, number 1, and these 3. I don't think.
Does it say x minus 4?
Where?
The power rule. Or x minus 3.
This is x squared.
Up one.
Here?
Yeah.
Right. X to the, for any n not equal to negative 1. That's what it says. For any n not equal to negative 1. This says x to the n plus 1 over n plus 1.
Okay.
I'm sorry, it's kind of blurry.
Yes. What power is x raised to?
There's an n.
This is x to the second.
Can you read the exponential rule?
Exponential rule says the antiderivative of b to the x power dx is equal to b to the x over natural log of b.
Do you know what page is on?
It's in 3.4 and 3.5, I think. I don't know what page. Let me just make them a little bit bigger so everybody can see them. There's that one. Everybody got that one? Whenever you have x to the negative 1 in your term, that x to the negative 1 is going to be natural log of an absolute value of x plus c. And there's an example right there. You pull the 4 out and you have the antiderivative of 1 over x. So that antiderivative of 1 over x is natural log of x. Actually, you need to put absolute values there because you can't take the natural log of a negative number. So you have to put absolute values. That's why it has it there. So that's an error. But anyway, 4 natural log of x plus c. All right? Everybody got that one? This one? How's that? Is that a little bit better? Now, this one takes a lot of thinking. The antiderivative of e to the x is what? E to the x. Maybe I just should give y'all all e to the x's. Derivative e to the x's and the antiderivative of e to the x. Everybody make 100? No, somebody would miss it. Yep, somebody would miss it. And here's the one you asked about. The antiderivative of b to the x power. So that means instead of e to the x, it's 4 to the x, or 5 to the x, or negative 3 to the x. whatever the case may be. If it was 4 to the x, then it'd be 4 to the x over the natural log of 4.
B to the x.
B to the x over natural log of b. Okay?
You say that's 4 down there?
What?
Is that C prime or 4? At the bottom.
This is C.
C prime.
Everything is C.
Oh, it's
Plus
not,
C.
It's not C prime, it's C.
C. Everything is C. Everything is plus C. Remember, some teachers will mark it wrong if you don't put plus C. Wake up. Like you ever get one of those dazes where you stare at something and you can't stop staring at it? What causes that? Huh? Daydreaming? See, that's why you're going to fail the class.
Math is just so interesting, though. It's just.
Yeah, it is. It can be. It can be for a lot of people. That's why we got people that build bridges. All right, and this is what we did yesterday.
So, what is the, on the simple power rule, x to the what? In the very beginning?
X to the n dx is equal to x to the n plus 1 over n plus 1 plus c. And we did that yesterday. We did 3 or 4 problems like that yesterday. Yes?
Because the x is -1, can you still do the antiderivative of it?
Yeah, that's this one right here. Right there.
Okay. Got it.
So if you have x squared, then that's going to be x to the 3rd over 3 plus c. If you have whatever this is, x to the 1st power, that's going to be x squared over 2. That's it.
Or is that the same at the top?
These are examples.
Okay, I'm good now.
And there's a page in your book which I tried to cut it out. Well, let me try it again. Hold on. Let me go here. Let me go here. Where's the dang book? Give me a second to find it. There it is. I'll try to do this. Okay. That was what I was trying to pull up a while ago. What I'm going to do is move it over and pull it down so you can see it. There's your derivative rules right there. So make sure you got them written down correctly. And I'll move them down. Here's the constant rule. The antiderivative of any number is that number plus x or times x. So the antiderivative of 4 is 4x. The antiderivative of -2 is -2x. The antiderivative of 1/2 is 1/2 x. And you could think about that. What's the derivative of 2x? 2. So what's the antiderivative of 2? 2x. Okay? The power rule, we just talked about that. That's what we went over yesterday. If you have a function that's x to the 5th power or x to the n power, then it's going to be x to the n plus 1 over n plus 1. So if you have x to the 5th power, that's going to be x to the 6th over 6. This is your x to the negative 1 or 1 over x rule. If you have an antiderivative of, or a function of x to the negative 1 or 1 over x or 4 over x or whatever the case may be, then that's going to be your constant. Whatever your constant is, 1 times the natural log of x. Absolute value. Yes, sir.
Why do they have the n plus 1 for the antiderivative, for the simple power rule?
Where? Right here?
Yeah.
That's how you do it. That's, in other words, you take this number, you leave it alone, then you raise this to the next power, and then you put it over that power.
Okay.
They're showing you how to do it. Here's your exponential rule. If you have 4 to the x power, then that would be 4 to the x over natural log of 4. And this one's the one you might need to write down. E to the x is e to the x. Here's the rest of them. E to a constant of x, e to the 2x, is going to be equal to e to the 2x over 2. Now you might see that one again. And then write down the last two, last three, natural log. This is on page 372, so you need to write that page down in case you need to look it up. And what I would do before the test is I would print this out and have it on the test. Because all you have to do is go through and write an example for each one. And I just gave you examples to write. Here's one. F of x is equal to 4. The antiderivative of 4 is equal to 4x. Power rule. 4x squared would be 4x to the third power over 3. Here's 4 to the negative 1. That would be 1 over 4. And then you would take the derivative of that, would be the natural log of whatever it comes out. I'm sorry, 4 natural log of x. This one, I gave you an example of 2 to the x power would be 2 to the x over natural log of 2. E to the x would be e to the x. E to the 4x would be e to the 4x over 4. Natural log of x, well, that's pretty self-explanatory. Natural log of x would be x, natural log of x minus x. The sine rule, the antiderivative of the sine is the negative cosine, and the antiderivative of the cosine is the sine. It's kind of the opposite of the derivative. And that's just the sum and difference rules. You don't really, I mean, if you want to write them down, that's fine, but we did that yesterday. You know, 3x squared plus 2x. What's the antiderivative of 3x squared plus 2x? Well, you use the power rule for two terms. You put a plus between them. Just, that's all that is. Okay, I don't really want to spend a lot of time on that because I think y'all know how to do that. All right? And that's those rules. The only other rule I want to pull up today, and I'll put all this together, just hold on. I don't want you to get all crazy on me. Let's go ahead and get out of this and go back to this and bring in one more. The only other one I want to show you today is these two. Just let me go find it because it ain't gonna, it's not gonna pull up nice. So I'll just find this one too, and that way you'll have the page number. There's Riemann's. They don't even call it Riemann's, but it's called Riemann's. That's on page 375, but I'm not going to test you on that. But if anybody asks you what Riemann's is, that's what you tell them. There we go. This is on page 378, and it's the definite right in there. Definite integrals as areas. And it's talking about above the line and what? Below the line. And it talks about the negative of the area of the region between f of x, blah, blah, blah. And I basically told you that. And they give you an example on the next page. And this is on page 379. So that's what I was going to show you right there. This right here, negative, so minus antiderivative plus antiderivative minus antiderivative. And that's what there it is right there. This one would be plus, minus, and what? Plus. So make sure you write those down, page 379. There's those two. And then the only other thing I want you to write down today is the difference of two curves. Trying to find it. Hold on. Yes, there it is. Oops, sorry. It's the wrong button. I suck. There we go. Write that down. Page 385. Now we're going to spend today's class on this. Okay? And the reason we're going to spend it on this is because this is probably something you haven't seen before, whereas you have probably figured out that a lot of the antiderivative is memorization and plug and chugging, right? Just like I said, e to the x is e to the x. That's memorization. And the others is plugging and chugging. But what about this guy? This guy, you have to actually do some thinking. And that's why I want to go ahead and start on this, and then we can work on the, from here on out for the next week, we can do nothing but problems. Okay? Capiche? So, what does this mean? Well, let's get our handy dandy whiteboard out. And let's go. I'm having a brain bubble here. There we go. There we go. And put our handy dandy straight line maker. And we're going to draw a line and a line there. And we're going to draw a curve that represents y is equal to x squared, which looks terrible. And that's f of x is equal to x squared. And then we're going to draw a red line, and we're going to do that line right there. And that's going to be g of x is equal to x. Now, where do you think I want to find the area? I want to find this area right here in green. So what do? Well, you just sit there and stare at it for 15 minutes, right? First, you got to find the intersection points. The what? The orb of confusion, right? Find the intersection points. Write that down. Number 1. Go away. find the intersection points. How do we do that? Somebody tell me from your algebra days, how do you find the intersection points? All I heard was and I heard calculate. Enunciate and volume. Two things that you need when trying to talk. Y'all ever listen to your voicemail messages? Okay, that's the way y'all sound when y'all answer questions. It's almost like when you don't study for a test and you go in there and you try to write an answer and you write it to where the teacher won't understand it, and maybe you'll get credit for it. Y'all don't do that, do you? Okay, now let me go back and restate the question. How do we find in algebra, that's what y'all had like 2 or 3 times before y'all took this class, how do you find the intersection points of 2 lines? By looking at it for 15 minutes. Set them equal to what? Each other. Thank you, class. Set equations equal to each other and solve. So do that. If you can't, then chalk that up as being a failure. So x squared is equal to what? And solve. What?
It's like basic math.
Well, it should be, because you should have had it before. Of course, you don't have to blame yourself. You can blame the teachers before you had this class. That's what people usually do. So that's going to give us x squared. X squared minus x is equal to what? 0. And then that's going to give us x, parentheses, x minus 1 is equal to 0. And our intersection points are x is equal to what? 0 and x is equal to what? 1. Now go ahead and take your handy dandy calculator and graph it so you can see the actual graph. The first line would be x squared. The second line, make it a little bit thicker and be x. And then check your intersection points. So I'm going to pull up my handy dandy virtual calculator, which everybody should have one in their pocket. Heck, got 15,000 applications running at the same time. Now, the reason you need to do it on your calculator is sometimes on a test or whatever, you're not going to have time to algebraically find it. So you need to learn how to do it on the calculator. Y is equal to, I thought I hit the on button, did I not? Y is equal to x squared. So dang old x to the second power. And then I'm going to make this guy thicker and call him x. And graph. Now, of course, I can't see anything there, so I'm going to go in and zoom box, and I'm going to zoom in to where they intersect so I can actually see something. Now, you can do this with a window also. And there's your area between two curves. Right there. So now I got to find the intersection points. I got to back up a little bit because I'm still not where I want to be as far as my zoom. I want to see the origin a little bit better. So I'm going to go to the middle here and go a little bit to the left of the area so I can get my, there we go. And then I go back, zoom window or zoom box, and I'm going to get my origin in there. There. And of course, like I said, you can do this with window, but there, now I see a better picture. Okay, so I'm going to do second trace, which is calculate, intersect, number 5. And I'm going to go down here and I'm going to do first curve, which would be the parabola, and the second curve, which would be that. And my guess is right in there. And there's the intersection, 0, 0. That's one intersection. We got that right here, 0. And then let's check the other one. Second, trace, intersect. And go up here. And there's that one. And my guess is somewhere right in there. And there is our intersection point there at 1. So at 0, x is equal to 0 and x is equal to 1, our graphs are, our two graphs are intersecting. That's how you find it algebraically. You set them equal to each other. This is how you find it on your graphing calculator. And I would highly suggest that you practice that on your graphing calculator because you're going to need it for the test. Okay? So, we've got this guy. And I'm trying to, there we go. And now we've done the first part. Now what's the second part? Well, plug and chug into the formula for number 2. Plug into difference area between two curves and evaluate at A and B. Well, what's A and B? Well, you just found A and B. A and B is going to be equal to your 0 and 1 because you're going from here to here. And let's take our handy dandy straight line maker. Here's your A, or B, sorry. Your B, and of course your A is right here. I'll just make a big dot right there. So there's your A and B. Of course, your biggest number is going to be what? B. And your lowest number is going to be A. So when you get through, this is what it looks like. Antiderivative of, what's our number? 1 to 0 of x squared minus x dx. Okay, now do it. Well, there's not anything you can subtract, so now you just take the antiderivative. Excuse me. That was a half of a yawn. And plug and chug. So what's the derivative of x squared?
X to the third.
Over 3 minus x squared over 2, evaluated at 0 and 1. I'll do 0 for you. 0 is going to come out to be 0. Hopefully y'all figured that out. I was going to try to make that smaller. Whatever. Oh, well. All right, so that's going to be parentheses to the third power over 3 minus parentheses squared over 2 and plug in a 1. Well, we all know that 1 to any power is 1, so that's going to be 1/3 minus 1/2, and we got to have a common denominator of 6, so that's going to be what, 2/6, right?
Yeah.
Minus what? 3/6, which is equal to 1/6. It's equal to negative 1/6, but why am I not putting negative 1/6? Because area cannot be negative. Now, when I say negative, when you see a negative area, that means it's below the x-axis. That's all it means. The area is still 1/6. Now, why it comes out negative, that's just the way it comes out. But this area in here is negative. Now, you could probably, the reason it's negative is because I took the x squared minus the x. If I took the x minus the x squared, it would come out to be positive 1/6 probably. And again, it doesn't matter. You see it's above, so it's positive 1/6. All right, let's do another one. Let's try something simple, another simple one. Let's go with f of x is equal to 2x cubed. So that means that thing is going to look like this. And g of x is equal to 4x. So you probably got something that looks like this. Something like that. So you might have a little bit of area down here. You have to do it on your calculator to see where they cross. I'm going to do it algebraically. You check it on your calculator. So 2x cubed is equal to what? 4x. So 2x cubed minus 4x is equal to 0. Factor out of x, or 2x, and that's going to give us, that's going to give us what? X squared minus 2. And that's going to give us 2x is equal to 0, so x is equal to 0. And x squared is equal to 2. X is equal to positive or negative 4.1 or 1.4. So this thing crosses at, it intersects at 0 right here, and at 1.4, which is right here, and what? Negative 1.4. So I need to draw my, I need to fix my drawing because it's not exactly the way it needs to look. So I need to go back this way. Like that. And the straight line, something like this. There we go. So at negative 1.4 is hitting down here. Is it symmetric? Yes or no? Yes. Do you have to do it from negative 1.4 to 1.4, or can just find the total area? Can you just multiply 0 to 1.4 by 2? Yes. To find the full area, you can multiply by 2 or go from negative 1.4 to positive 1.4. I'm going to finish drawing a little bit. Make this right here. So we are finding this area. Now, if you apply the positive and negative to it, basically what's going to happen? They cancel each other out. If this was a business type application, you got the negative, let's say that the negative area comes out to be negative 4. Then what's the positive area? 4. And what happens? They cancel each other out. That way in business, you know, exactly, the break-even point. And that's what you interpret out of this graph. Okay? So let's take our handy-dandy, what you call it over here? What do you call it? Stylus, whatever. And really? Try it again. Not ready to quit. Get everything that time? Oh, forget it. Just go to the next page. Now, actually, which function is the higher function? Technically, the 4x is. How do you know that? It's above it, right? So you could actually take g of x minus f of x. Doesn't matter, okay? Because the area is still going to be the same because you take the absolute value because area is always positive, kind of like distance. So I'm just going to take my higher, and how do you determine what's higher? Well, take x is equal to 1. X is equal to 1 right here. Plug it in. X is equal to 1. What's 4 times 1? 4. What's 1 times 2? 2. So which one's the higher function? The 4x. 4x is the higher function, so you always want to take the highest minus the lowest, so we'll do that. Go here, antiderivative of, I'm going to do 2, antiderivative from 0 to 1.4 of, what is our function? 4x minus what? 2x cubed dx. So that's going to be 2 brackets 4x squared over 2 minus 2x to the 4th over 4 evaluated at 0 and 1.4. Now I'm going to cancel a little bit to make it simple. 2 brackets, that'll be 2x squared minus what? 1/2 x to the 4th. Evaluated at 0 and 1.4. I'll do 0 for you. So that'll leave you with 2 times 2x. I'm sorry. Oh shoot, I also forgot I'm not recording. Am I?
Yeah, you're recording.
Oh, I am, okay. Okay, 2 parentheses squared minus 1/2 parentheses to the 4th, and put your 1.4 in here, and 1.4 in here, and that's going to give you, you know that 1.4 squared is 2, don't you? So that's going to be 2 times 2 is 4, so that's 2. That's going to give you 4 minus 1/2 of 1.4 to the 4th power. Well, 1.4 to the 2nd power is what? 2. So that's going to be 2 to the 2nd power, which is 4, right? Somebody check my math. What's 1.4 to the 4th power?
3.84.
Okay, it's 4. The reason is this is supposed to be 1.414, blah, 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 the square root of 2, whatever the square root of 2 is. And that's going to be 2 brackets 4 minus what? 2. And 2 times 2, 4 minus 2 is what? 2, and 2 times 2 is what? 4. So the whole area of this function is what? 4. So you could actually say that the bottom half is -2 area, and the top half is what? +2. And what happens if you put the two areas together? They cancel out. Did anybody do it from -1.4 to +1.4? All right, y'all do that. Do -1.4 to +1.4. And see if you come out with the same thing. If you come out with the same thing, then you know what you're doing. If you don't come out with the same thing, you can chalk that up as failure. You already done it?
Well, we need to do this a little bit the way I did it the first
Oh, you did
time.
it the first time.
Yeah.
So instead of 4x minus, what was it?
2x cubed.
2x cubed. So, of course, this comes out to be the same. 4x squared over 2 minus 2x to the 4th over 4, evaluated at negative 1.4 and 1.4. And that's going to give us 2x squared minus 1/2 x to the 4th, evaluated at negative 1.4 and positive 1.4. So, 2 parentheses squared minus 1/2 parentheses to the 4th power, brackets, minus brackets 2 parentheses squared minus 1/2 parentheses to the 4th power, close brackets. And what do we put here? 1.4 and 1.4. And what do we put here? Negative 1.4 and negative 1.4. Negative 1.4. So 1.4 squared is 2. 2 times 2 is 4. Minus 1.4 to the 4th power is 4. 4 minus or times 1/2 is what? 2. Minus negative 1.4 to the is 4. 2. 2 times 2 is 4. Minus, same thing here, negative 1.4 to the 4th power is 4. Half of 4 is 2. 4 minus 2 is something ain't right. I messed up. Okay, that negative. Something's wrong. Something's wrong. What's wrong? Somebody help me.
That's what I got to. I did it a bunch of times.
Oh, I know. It's telling you it cancels out. That's what it's telling you. 4 minus 2 is what? 2. And what's 4 minus 2? 2 minus 2 is 0. And why does it show that? Because on the business end, you've got a negative and you got a positive area, and they cancel out.
So what's the answer? What's the answer?
Well, in this class, it'd be 0 because they cancel it out.
Okay.
Now, if I asked you for the full area, it would still be 0, but you have to apply the negative and the positive. Okay? Most of the time, when you get the area above, both of them are above, you're going to have a full area. If you have anything below the x-axis, then that's going to play into the canceling out theory. Okay? So the answer would be 0. And I said in the previous question and previous problem, they cancel each other out so that it would be 0. Okay? Now let's do one where they don't give you a function. They just give you one function. And I'll pull one out of this. Let's go with f of x is equal to we'll use our I'm thinking. I know it's hard for me to do. How about negative x squared plus 4 and y is equal to f of or g of x is equal to 0, h of x, no, I'll do this, that'll mess you up. Hold on. I'm going off of one of these in the book, the way they've got it kind of messes people up. Y is equal to 0 and y is equal to 5. No, x, sorry. There we go. Now, the best thing for you to do is sketch this. I hope to God it works. Sketch it. Because you're not going to be able to put the x is equal to 0 or x is equal to 5 unless you change it to parametric equations. So when you sketch it, you should get a parabola at vertical shift of what? 4. And it should look something like this. And I'm going to take my handy dandy highlighter. I'm going to highlight this. What is y is equal to 0? What's y is equal to 0? That's the what? And x is equal to 0. What's x is equal to 0? It's a vertical what? Line. And what is that? That's the y-axis. And then what's x is equal to 5? What is that? A vertical line at what? 5, which I don't know if it'll work or not, but we're going to try it. 5 might be right in there. Let's see what the, may not work. Negative x squared plus 4. Let me do a, let's see where it crosses the x-axis. It may not work. Negative x squared plus 0x plus 4 is equal to 0. Negative x squared plus 0x plus blank is equal to negative 4 plus blank. Half of 0 is 0. 0 here, 0 here. So that gives us x negative, oh shoot, it doesn't make any difference. Now x squared, x plus 0, quantity squared, is equal to negative 4. Be a positive 4, wouldn't it? No, it's got to cross. It's got to cross the x-axis. Somebody graph it. Where does it? I'll just graph it on the calculator. I don't feel like doing it right now. Somebody tell me what it is. Y is equal to what? Negative
X squared plus 4.
x squared plus 4. Yeah. Okay. Zoom 0. I don't care about that line. I just want to see where it crosses. I don't think it's going to cross. Zoom. I'm going to change it. Just hold on. Second trace should be 2. 0. Left bound. Right bound. Yeah, it's 2. So change this to 2. Change x is equal to 5 to 2. Now here, they didn't give us, or I didn't give you any formulas. I just gave you vertical what? Vertical lines.
What is the x squared plus 0 squared? X equals negative 4 up near your x.
Where?
Look next to gx. You have written x squared.
I was thinking. Don't even, I was thinking. Don't even. Okay. So it's this area right in here is we want. So it's going to be right here. Let me get rid of my other clear. There we go. And I'm going to blow that up. Zoom box. There you go. Now let's change this to this. And change this to this. So here is one border, and here is the other border. Of course, it doesn't relate because it just stops right here. So that one, you don't really need to extend it up this way. It just stops right here. And then, of course, the other one, I think I made it yellow. Is this border right here. And it stops right there. So you're wanting this area right in there. Okay? So it's again, the interpretation, there's three factors in this class: interpretation of graphs, algebra, and calculus. You have to have the algebra to do the calculus, and then you have to interpret the graph to set up the calculus. You see how it all fits together? Yes, Hubert. No, Hubert. You suck, Hubert. Thank you, class. Nobody's going to talk. I done wore y'all out. Is that what it is? Okay, I can't get my... There we go. All right, so which one's your highest function? Well, negative x squared plus 4 minus 0. And where are we going to go? From 0 to what? 2. So you start your function or your integration. 0 to 2 of, I done forgot the function. What was the function?
Negative x squared plus 4.
Negative x squared plus 4 minus 0 dx. Now the reason I put the minus 0 in there is I'm letting y'all see that I'm taking one function and I'm subtracting what? The other function. Even though I didn't give you a function, I gave you a parameter. Here's your other two parameters right here, 0 to 2. And that's going to give you antiderivative from 0 to 2 of negative x squared plus 4 dx. And that's going to give you negative x to the third over 3 plus 4x evaluated at 0 and 2. And that's going to give you negative 8/3 plus what? 8 over 1. Well, we've got to have a common denominator. So that 8 over 1 is going to turn into 24 over what?
3.
And negative 8 plus 24, dang old 16. Somebody help me out.
Yeah, 16.
Over 3, which is equal to dang old 3.33 or 5.33. Y'all check me.
Yeah.
So the area under that curve is 5.33 units. Now this was a highway and it was going around a house or around a pond. And I used a highway because, wait a minute. Here's your dang old pond. And you were putting a highway around a pond, a horizontal curve. A horizontal curve, that would be encompassing 5.33 acres. If you were doing this in feet, linear feet and linear feet here, that would be 5.33 acres. The blue area would be 5.33 acres. Huh? Well, you see how this is applicable in engineering, and it's also applicable in your business, because in business the area under a curve is stuff you need to know. And it's not going to be acres, it's going to be profit and cost, and that's why you need to be able to do it. Okay? Who's got a question? Now, again, this book is super inflated, all right? It takes 5 sections to tell you how to do 3 concepts, all right? I've shown you all of chapter 5, or 3, sorry, okay? Now, what I'm going to do is I've already put like 3 sections of chapter 3 up, I think.
Chapter 5.
Are we in chapter 5?
Yeah.
Okay. Chapter 5. I'm going to put probably 2 more sections up. One is going to be logarithms, what I showed you today, and we'll cover those tomorrow or whatever. And the other is going to be a good many problems on finding the difference between 2 curves. Okay, find the area between two curves. You may get a lot of problems on that one. And then after that, we should be ready for the Unit 3 test. Whatever this is, yeah, Unit 4, I switched it. Unit 4 and Unit 5 I switched. This will be Unit 4 test, which I will probably post, what's today? Friday-ish, somewhere around there. Okay, so we'll be working on this for the next couple of days. Who's got questions? Okay, let me get the roll, and then y'all can skedaddle.